Alright, so I found another relay in my toolbox, and this is a Volkswagen relay. And I just wanted to show you, again, how common that wiring schematic is. It's pretty much the standard for relays. And this relay is a different relay than the first one. Again, 85 and 86 are the control side. And then 30 is the high amperage input. And then on this relay, 87, and they call it 87B, is you can tell that they're both normally open. Okay, when they're drawing schematics, they will definitely draw a connection, like maybe right here you can see this line coming to the right. They draw that thick dot. That's a connection. So when they choose to draw it with it open, that's a normally open schematic, a normally open switch. So what that means is, unlike the first relay, KO30 and 87, both of them are normally not touching 30. So when this relay is unenergized and I put a voltmeter from ground to either of these two 87s, I would see 0 volts. At the same time, if this KL30 was straight to the battery, then obviously if I tested that with the voltmeter, I would see 12 volts. And again, the point of the relay, it's a low amperage switch that switches high amperage loads. So I already popped this one loose, and here's what this one looks like. So it's showing you here that 87B is this one in the middle, and 87 is the one right next to it. I think 87A, whether they choose to call it A or B, depends on where the leg, the actual spade is, this terminal, physically is on the board. I think 87A would be somewhere else. I think there's a standard for these, so I might be wrong. But this is a double pole relay. Both of the 87s on this one, they're tied together in parallel. Means they both get the input power at the same time and share it. So here is how this one works. If I can figure it out myself, right here. So look. So in its normal unpowered state, that one on the bottom is touching this plastic, so that's not passing any power through. And this other side is just to open air. It's not it's not touching anything down there, that contact point. Both of these are, just like the schematic said, normally open. And so then when you put power to it, the magnet's going to draw these two in. Yeah, right here. Draw them in. So that's what wears out. And on this kind, the way this is designed, if you pop that spring off, you can usually pretty easily get that plate off. And that thing fell on the floor. Usually. Like I said, sometimes you end up destroying these just to inspect them. So don't do this unless you have a new one ready to go, obviously. But I'm doing this because I want to show the wear and tear on the points here, the contact points. So there's some wear, but you'll find relays when they actually fail and stop powering up the device that these will be very pitted. They'll be very worn down. This still has some life left in it. It's too bad I just destroyed it. But so Now imagine on this relay, I don't know what the exact amperage rating was, but let's say this could handle 30 amps. And so we had two legs of this circuit that we could have powered off of one high amperage input that would have gone to terminal 30. So, you know, it just, if you had the correct relay that was powerful enough with enough rating, amperage rating, you know, we could have wired our wiring diagram in our car. Maybe this would have powered the left headlight and that one would have powered the right headlight. One relay perhaps could have been powering both of our headlights. You know, that you can just do whatever you want with relays. And let's see the inside of this point here, these 2 points. Oh, that just popped off like a terminal. Maybe on another day. So I touched there and here. So you can see a tiny little bit of wear in the corner right there of that, on the edge of that point. So again, since I'm seeing this printed on the bottom of the panel here, even if I didn't have this wiring diagram and I memorized it, or I just, you know, could look it up somewhere, I still could take this relay and either diagnose this car, or if I'm doing my own custom work and I just found a relay in the toolbox just like this, I could put my high amperage supply to terminal 30, and I would have to pop it open or use a voltometer, a multimeter, and I would, if I wanted to figure out, okay, I know I have two 87s, you know, because I know 85 and 86 are the control side, so I know those two are not options for the load. I know 30 is the load supply, so I know, just counting the pins, you know, here, that I would have had two outputs for my circuit, for the loaded side of the circuit. And if one or two was normally open or normally closed, that I would not know. And so I just destroyed this relay. But if I would have put my meter on continuity, put one clip of the probe to 30, and one at a time went to 87 and 87B, the meter would have beeped at me. And if it did, if let's say it beeped, okay, then that would tell me I have continuity with an unenergized relay. And that just, it's all in how you design your circuits, what you need. Do you need a normally open relay? Do you need a normally closed relay? It's all in how you design it and, you know, what your circuit calls for. But I could have known, even if that, you know, like I said, I'm just trying to prove to you guys and show you that you don't need the little wiring diagram on the side if you just understand that there's a standard involved here. There's options, so you need to take your meter and see, do you have resistance? Do you have continuity to terminal 30 on either of the two outputs when this is de-energized? I would have tested this and it would not have beeped, and I would have known this is a normally open relay, meaning those points, the outputs are normally, it's an open circuit to 30. They do not touch 30. And therefore, it, you know, the opposite is true. When 30 gets power, you know, and the relay switches and does its magic, 30 is going to be supplied to these two. So that's about it. I don't know what else to show you when it comes to relays. You do buy them based on an amperage rating, so you guys can try to figure out. Go look up an electronics store catalog, you know, and like Radio Shack, I guess, and go buy some relays for your old cars. Do the headlights. If you put in an electric fuel pump, instead of running your fuel pump to a switch and letting that switch handle all the high amperage, run it to a relay, and then you can use, I had an El Camino that I used the fan switch, the hot, the 1, 2, 3, 4 fan speed, and on those, I think it was speed 4 was basically like an on-off switch. It bypassed the resistor and gave the fan motor 12 volts. And so I used that to trigger my fuel pump relay. It was kind of like a anti-theft, way of turning on the fuel. So if a thief got that car, he could have hot wired the ignition switch, but he would have had no fuel, and eventually the carburetor would have died out. And if he didn't know how to turn the fuel pump on, so that's another good thing about relays. They can help you to get involved with anti-theft devices on anything electric. You can basically get really creative on the control side of this.